if you want to understand how to set up these jobs, look at some of my other videos. But the idea is, let's say once a job runs and this invoke ingestion API is failing, but that already persists all the data sets. The idea is each of these Databricks jobs that we've set up, the Epic notebook or the Kairos Bronze notebook, each of these persists data back to our centralized data store. In Databricks, that is called Unity Catalog. So if we look at this, the Epic Bronze table, for example, immediately right here, as it got, so in this code, we get the Epic departments, we create a data frame from this class, of the data we get back, and then we run this function called create delta table. It's a local function that I've created. It persists data back to a table called incoming Epic departments in a catalog called dexcare job dev. So dexcare job dev is, so okay, let's first talk about how is data structured in the Unity catalog. So the Databricks Unity catalog can bring in data from basically any structure and format. And the top level, it has 3 levels of partitions. The top level is called the catalog. In this case, ours is called dexcare job dev. The second level is called a schema. In our case, we have bronze, gold, and bronze, gold, and silver. Information schema and default are folders that exist in every catalog. And for each of these schemas, we have certain tables that get created. If you look at bronze, we have the incoming Epic departments, incoming Epic providers, incoming Kairos locations validated. This is Pydantic validated, and so on. And we've set up 2 kinds of metrics called the drift metrics and the profile metrics. This is to track the quality of tables that are created. So if we look at any of these tables, we can click on them. There is an overview. We see this different kind of sample data that is pulled from each of these tables. The details about how are these stored, different properties. For example, the change data capture is turned on for these, so we track the diff between data that's already there versus what gets written. Then we have certain level of permissions. We can actually apply different kind of permissions to each of these tables, so different folks in the organization have access to this table. And then we have history about the metadata to table structure. So this is like schema level changes to a table. And we have lineage. So for example, for incoming Epic departments, these are the different sort of jobs and pipelines that it's associated with. One very core and important feature that we get with table lineage is this lineage graph that we can see visually. So the table that we were at was incoming Epic departments. So as you can see, the incoming Epic departments, which has all these different columns, it then is used to create the Epic departments enriched. And this one has 8 columns, this one has 9 columns. So we're using this, for example, to add this visit type departments, and we can see that visit type departments is a combination of all of these different fields. But we can not only that. So these 2 were bronze tables, because remember how we said this is the catalog name, the bronze is schema name, and this is the actual table name, the third part of this. And this is a silver table and this is a gold table. This is a complete lineage of Epic departments, how it's used only for that purpose. But we can actually see every single field that's created or associated with it. So this gold table was locations. So look, all the locations that we get for Kairos, for Tampa from Kairos and from Epic, and all of that combined with the Epic departments table. And we get all of these different sort of tables, and we have enriched Kairos clinicians, provider clinicians, and we have enriched Kairos clinician locations, because there's 2 kinds of locations. One is clinician locations and one is marketable locations. So as you can see, this table sort of really, the lineage for this kind of goes on, and we can track different kinds of columns that are created across each table, what are the different kind of transformations that we run for each, and this can really go on. So these ERD diagrams or entity relationship diagram kind of paint that full picture of how we are creating each table, what happens, how does data flow, and it also gives us an idea about, let's say, for example, I say last week, it gives us a historical significance of when each table was created and how. And this paints a picture for the entire pipeline, and not just for the table that we're looking at.